So children, good morning. So let us continue. So in the previous session we were talking about what is electronic configuration. And what is electronic configuration? The periodic arrangement of electrons in an atom. And where are these atoms, electrons being present in an atom? In the shell, which will have subshells. Okay. So last time we learned that every atom will have shells. And what are those shells called as orbits, or which are designated as K, L, M, N and so on, isn't it? Now this is also called as principal quantum number, about it which you will be learning in the higher classes. So right now let us only focus on what is electronic configuration. Now each of this orbit is given a value, okay, and the value begins from where, children? 1. Fine. And as I have told you, the electron, and what is the rule for filling the electrons? The electron will first occupy the lowest energy level, or the innermost orbit. So which is the innermost orbit? K, then followed by L, then followed by M, and then followed by N. So within the orbit, they will occupy the least subshell. So which is now how many subshells are there? Orbitals are there? S, P, D, F. So where S has capacity of 2, P has capacity of 6, 10, D 10 and F 14. So this is what we have learned in our previous standard. Now let us know how the arrangement, or how electrons will be filled, or as what rule is being followed. Now this was given by a scientist named as Molar. So we also call it as the Molars Diagram. Now what is the arrangement, or how the arrangement is done? So he started with the innermost or the lowest energy level. So which is the lowest energy level? K, isn't it? K orbit. And so and what is the designation we have given to K orbit? 1. Fine. And what is the subshell present in this? S. Okay, small letter S. Clear. And what is the capacity of the S orbital? It is 2. Fine. Then he started arranging them vertically. So after first shell, what comes? The second shell, that is L, is represented by what? 2. Now this second shell contains 2 subshells. What are those 2 subshells? S and P. Now this P-shaped subshell is of which main orbit? That is second. So we'll designate it as P. So 2S, 2P. Now S has capacity how much? 2. And P has capacity how much? 6. Then comes now the third orbit, okay, or the third shell. And what is the third shell? M. So what is the designation? 3. Again, this will have what? The first subshell will be what? S. And as I have told you, the number of the shell will indicate the total number of subshells. So it means this third shell will have 3 subshells. And what are those 3 subshells? S, P and D. So first the electron will enter into S. Now S capacity is how much? 2. So after 2 electrons are filled, then the next electron will go into the P orbital. Which P orbital? The third shell's P orbital. Then P capacity is how much? 6. Okay. Then after filling this, it will enter into the D orbital. And now D capacity is how much? 10. Fine. Similarly now let us continue. So then comes what? 4. So 4S. Now since the value is 4, that means how many suborbitals are there? How many orbitals are there? 4 orbitals. So S, P, D and F. Okay children. So since these suborbitals belong to, orbitals belong to 4th shell, we will be mentioning it as 4p, 4d and 4f. Okay. So now let us write it as 4p 6, 4d 10 and 4f 14. Okay. So like that only. Now then comes now 5th. So 5s2, 5p6, 5d10 and 5f14. Since we have not discovered the elements to this capacity, we will not write the next suborbital. As of now, the element so far discovered could fill only till the F subshell. Okay, so then comes similarly, so we will not write about it. So 6s2, 6p6 and 6d10. So I will not write the rest. Similarly, now let us go to 7. 7s2, 7p6. Fine, children. Now, so what is the order what order will be followed? It will be from the lowest. Now, who is the lowest? 1. So, if I start writing in a linear fashion, it comes like this. What it comes as 1s2. Then followed by whom? 2s2. Now what he did, he started drawing the diagonal lines downwards, in the sense the tail end towards the head. Okay, so first 1s2. Then again from here we will move back. So then comes what after 1s2? It will go to 2s2. Fine. Then after 2s2, where the electron will go? It will go to the second shell, p subshell. So let us now draw a line cutting down the orbital. Okay, so now you see, so first 1s followed by 2s, go back 2p, then comes to 3s. Again go back, who will come? p6. Okay, so then 4s, then again we move back. So who will come after 4? Which subshell will be coming now? After 4s2, it will again go to the third shell and D subshell. Now about what is the reason behind this, you will be learning later in your higher classes, but let us now know the order. So this goes as, okay, then 5, after 5 it then moves to what? 4D. Okay, children, so now I think you have got an idea. So accordingly, yes, so the path runs in this manner. Okay, vertically, diagonally downwards. So now first filled what? 1s2. Then comes what? 2s2. Then 2p6. After 2p6, let us move on to what? 3s2. And then followed by 3p6. Now after 3p6, where is the electron entering? Not into the third D subshell, but rather fourth shell S orbital. So 3p6 continues as 4s2, and then it moves to back. This is called as penultimate shell. Okay, remember children, about it detailing you will be learning in higher classes. Then comes what? 4p. Okay, 4p6, and then comes 5s2. Now after 5s2, again move back. So comes 4d10. So children, what comes? 4d10. Now follow the path. After 4d10, where is the electron entering now? 5p. So fifth shell, p subshell. And then after filling the fifth p subshell, it will then move on to sixth shell, s subshell. Okay, so like this will be continued. Fine. Now let us see what does this particular, now when I am writing like this, 1s2, what information are you getting from this configuration? Let us discuss. Okay, now so what does the value 1 indicate? Value 1 indicates the shell or the orbit, the orbit. So which orbit is this? First orbit or the first shell, K shell. Then what does this S indicates? The subshell. So then what does this value indicates? The total number of electrons. Got it, children? So now if you can recall, I mentioned you in the earlier session that every electronic configuration will help us to know three main things. Three main points. One, the shell, the type of subshell, the type of shell, that is nothing but orbit. Then the subshell, which is also called as orbital, and the exponent. Exponent will help them, or the power will help us to know the number of electrons. Followed, children? So keeping this only in mind, we are going to write the configurations. Now coming to in your 9th standard, what all you learned, it is right. but it is a shortcut method. Now when you are writing in this detailed manner, we are going to know exactly where the element lies in a periodic table. Now how does it help in? We will come to know once we start writing the configurations. Am I clear, children? Now today let me show you 3 examples of electronic configurations and 4 you take as homework. That we will discuss in our session. Okay. So now
Hello.
So children, now let us take an example and then we will understand how the arrangement of electrons can be done. So now let us start with the simplest one, hydrogen. Hydrogen, what is the atomic number? 1. So that means how many electrons are there in this? Only 1 electron. So as I have told, what is the first rule? It will enter into the lowest energy level or the innermost shell. Now as per this configuration rule, what is the lowest energy level? 1. So my configuration, first I will write the shell. So which shell will the electron of hydrogen enter? First shell. And in first shell, which subshell it will enter? S. Okay. Now S has capacity of how much, children? 2. But hydrogen has how many? 1. So therefore it will have the exponential value as what? 1. So now what is my configuration? 1s1. Okay. Now let us go to next electron. Next element, helium. What is the atomic number of helium? 2. Again, we have to follow the same rule. Okay. So first, which shell it will enter? First shell. Okay. Then which subshell? S subshell. Now how many electrons? 2 electrons. So S has capacity of how much? 2. Can it accommodate? Yes. So now the configuration of helium is how much? 1s2. Now similarly, let us move to next element, lithium, whose atomic number is how much? 3. So now again follow the same rule, go with the same rule. 1, okay, subshell S. How many electrons S can accommodate? 2. And how many are here? 3. So I can accommodate 2 here. Still one more is left off with whom? With lithium. So where will that now enter? Now it will go to the next subshell. And what is the next subshell? Next shell? Second. Is there any subshell in the first orbit? No. Other than S, there is no other subshell. So now it will move to second orbit. In the second orbit, which one it will enter? S. And S has capacity how much, children? 2. But how many more are there with lithium? Still more. 1 more to accommodate. So 1. So 1s2, 2s1. Similarly, let us take another one, lithium, beryllium. So now beryllium, how much? Beryllium is 4. So again, follow the rule. First subshell, first shell, first subshell. 1s, how many? 2. Remaining how many? 2 more. So enters the second shell. Which subshell? S subshell. And how many more electrons are there? 2 more. So now you see the shell is got filled. So 1s2, 2s2. Then comes what? Boron. Boron atomic number is 5. So it enters as again follows the same rule. 1 subshell S, electrons 2. So 5 minus 2, 3. So now goes to second shell, subshell S, electrons accommodated how many? 2. So 2 plus 2, 4. Still how many more? 1 more. Now after filling the second, after filling the subshell S of the second orbit, it will move. It will be in the second orbit only, but in which subshell? P subshell, accommodating how many? 1. So now if you just count up, children, 2 plus 2, 4. 4 plus 1, 5. So is it right? Atomic number? Yes. Similarly, 2 plus 2, 4. That is equal to beryllium atomic number. So this is how you will be writing your electronic configurations. Am I clear? Now all of you will draw the Molars diagram along with this arrangement in your notebook. Okay. So copy this in where? In your notebook along with what? Molars diagram, which I have shown earlier. Am I clear? And then you will all be writing the electronic configuration of the next 5 elements. That is, from after boron, what comes next? So after boron, comes what? Carbon. So carbon to neon. Carbon to neon. So you will write the configurations up till here, and then we will discuss in the live session. Thank you. Have a good day.